Hi, in this tutorial we are going to solve a question related to aromaticity. The question asks, in the figure below, the skeletal structures and ball stick models of three molecules are given. By considering all factors, evaluate the aromaticity of three given molecules, being as aromatic or non-aromatic or anti-aromatic with your reasoning. Let's start solving the question. These factors or these criteria for aromaticity, let's remember them. If a molecule is going to be aromatic, it should follow three criteria. The molecule has to be planar. Let's write here. And the molecule has to be cyclic and conjugated. And then the last rule, the molecule should have 4n plus 2 pi electrons, where n can be 0, 1, 2, any positive integer. So let's evaluate the aromaticity of these three given molecules based on these criteria. Let's look at for the first criteria, let's say it here, first criteria, planarity. Cyclopentadiene, if you look at the ball and stick model, you are seeing that this carbon has sp3 hybridization and it has 4 connection. For that reason, these two hydrogens are, one is out of plane and the other one is inside plane. So for definitely this molecule is not planar. So let's put a cross here because it is not a planar molecule. Let's look at the other molecules. Cyclopentadienyl anion and cation. They are based on the model. They are planar. And also, if you look at the hybridization of each carbon, all of them are sp3. Here, if you look at the structure, we have a lone pair. This looks like an sp3 hybridized carbon, but we can write resonance form by joining these two electrons here as a pi bond. For that reason, that's also we can consider this carbon as sp2 by considering other resonance form. Say yes and yes. Two molecules are planar, one molecule is not planar. Let's look at the second criteria, cyclic and conjugated. All molecules are cyclic, that is fine. And let's look at the conjugation. The first molecule is not conjugated, is not fully conjugated. Let's look at, we have double, single, double, single bonds, and since this carbon has 4 connections, so we cannot write any resonance form this molecule. So basically we cannot place double bonds here. It's against octet rule. For that reason, this molecule is not conjugated. It's cyclic but not conjugated. Let's look at the second and third molecules. The second and third molecules, they are cyclic for definitely. And how about the conjugation? Let's look at this molecule, cyclopentadienyl anion. It is a conjugated molecule because it has double, single bonds. You may say that we have two single bonds and it's not fully conjugated, but as you can see that we can write 5 resonance form for this molecule, and we can join a lone pair to the pi system. For that reason, this molecule will be fully conjugated. The same reason applies for the cation, since we can write 5 resonance form for cation, and the bonds here, 2 single bonds, they will be sometimes double, sometimes single in different resonance structures. So we can claim that this is also fully conjugated. So these two molecules fulfills the second criteria. How about the last criteria? Let's look at the first molecule, cyclopentadiene. It has two double bonds. It means that we have 4 pi electrons. How about cyclopentadienyl anion? We have 2 4 as pi bonds, and also a lone pair. We have 6 pi electrons. And let's look at the cation, cyclopentadienyl cation. It has 4 pi electrons because of these two double bonds. So let's look at which one is going to be aromatic, which one is going to be non-aromatic, and which one is going to be anti-aromatic. The first molecule is non-aromatic because it's not planar, it's not fully conjugated, and also it doesn't have 6 pi electrons, or it doesn't follow 4n plus 2 pi rule. For that reason, the first molecule is non-aromatic. Let's write here non-aromatic. The second molecule, let's look at it, is planar, cyclic, and fully conjugated, and it has 6 pi electrons, which it follows the last rule, Huckel formula, Huckel criteria, 4m plus 2 pi rule. So this is going to be an aromatic molecule. And the last molecule, it is planar, it is cyclic and conjugated, but it doesn't follow the last rule, 4m plus 2 pi rule. Instead of 6 pi electrons, we have 4 pi electrons. When we have 4 pi electrons, the molecule will be anti-aromatic. Okay, so basically we decided that the first one is non-aromatic, the second one is aromatic, and the last one is anti-aromatic. Let's look at what are the results of being an aromatic molecule and what's the result of being an anti-aromatic molecule. We are going to see two electrostatic potential map. One is for cation, and the second one will be for anion. Okay. Here, on the left side, this is the electrostatic potential map of anion. Anion was aromatic based on these three criteria, based on these three rules, and cation on the right side it was anti-aromatic. If you look at the aromatic molecule, which is the anion, you can see that electrons or the negative charge is delocalized over the ring, but for the cation the positive charge is localized, it is not delocalized. And another result for being aromaticity or not aromaticity, the bond lengths, for example in anti-aromatic molecule we have double bonds and single bonds, and in anion also we have double and single bonds. In anion, since this is an aromatic molecule, all the carbon-carbon bonds are equal. Since electrons are not localized in bonds, these 6 electrons are delocalized, we expect that carbon-carbon bond lengths should be equal. But in the cation, since it's aromatic, it's anti-aromatic, the pi electrons are localized. So basically this double bond, let's look at its distance, 133 angstrom, and let's look at the next bond, which is 157 angstrom. So basically this is really a single bond, and the other one is really a double bond. So there is no like resonance contribution basically. So electrons are localized. So in this question we decided, or we evaluated the aromaticity of 3 given molecules by following 3 rules: planarity, being cyclic and conjugated, and following 4n plus 2 pi rule. Thank you so much for watching.